Welcome to our final panel session of 2021. We should have a big round of applause. I cannot believe the day is here. We will be going straight from this session into our closing session, so feel free to go grab your coffee and keep your headphones on whilst we're doing it. We've got a lot to run through in our last session, resource efficient manufacture session. We are focusing on how we make efficient use of the resources we already utilise, but also on the design of more resource efficient manufacturing processes that use less energy. I'm going to ask you a poll in a second, so get your phones out ready. Less raw materials, and also to be able to make use of what one process considers waste product as the raw material for another process. We have got 4 speakers, not 3 if you were looking at your programme, and I am delighted that finally, and can we have a big round of applause, because we have Amy, who is a female on our panel. So big round of applause and welcome to you, Amy. I'll introduce her properly later. She's working with Martin at Booth Welsh, but it is great to see, and we need to push that diversity piece, as we all know, in this industry. Now, I have one last poll, so please get those phones out for me, and please make sure you answer that question. Can I see it? Team, lovely. What do you think is likely to have the greatest impact on your organisation's use of natural resources? I'm not going to read all of this out for the interest of time. It's on the app, and we would really like you all to poll this one for us, and we'll discuss this when we finish with our speakers. First up, let me introduce all of our speakers. We have Daniel Masenga-Grant. He's Environmental Lead for HV Systems, a company founded in 2017 based here in Glasgow. HVS is Europe's only startup focused on the design and development of zero-emission, hydrogen-powered medium commercial vehicles, MCV for short, you could have told me that, and heavy goods vehicles, HGV. So welcome, Daniel, who will be first up. Martin Welsh and Amy Dool, my apologies, at Booth Welsh, which is an engineering technology business. Martin is a member of the Scottish Government Life and Chemical Sciences Technology Steering Group. Amy's going to be starting off the session and tagging with Martin during that, so great big welcome to yourselves. And Bradley Wynn. Bradley is Research Director of the Advanced Forming Research Centre, AFRC, one of NMIS's specialist centres. He is our last panellist, so he is told me you are in for a treat. No pressure now, Bradley. So please get those polls, get those questions in early, because we are going to have a hard stop in this session ready for our keynote. But first up, please give a round of applause for Daniel Masenga-Grant.
Thank you very much. Can everyone hear me? Thumbs up. Great, yeah. Good afternoon. My name is Daniel Masenga-Grant, and I'm the Environmental Lead at HVS. I've always had a passion for the environment, and so I'm very excited that COP26 has come to my home city for these 2 weeks. This stems from growing up in the countryside, but also through my love of the mountains, lochs, glens, forests and beaches that make up our Scottish landscape. I've always been interested in the interactions between different levels of the environment and how we interact with that ourselves. How do we build the vehicles that we want and generate the energy we need without impacting that in a negative way? So what I want to do with my life, thank you very much. What I want to do with my life is to prevent more emissions than I create. In short, I wanted to be a net zero person. And so this led me to work at HV Systems, which is the company that produces zero-emission hydrogen electric vehicles. One of the great things about working at HV Systems is, as Sam said, we started 4 years ago in 2017. And when we started, it was just myself and the 2 founders in a tiny office sketching pictures of trucks on pieces of paper. And since then, we've grown the business massively. We've taken it through Brexit, through the pandemic, and we've built a world-class team with experience in automotive manufacture, the environment, infrastructure, hydrogen, logistics. And as a team, we often get asked, why hydrogen? But now, when we say back to base refueling, because of logistics often has set routes, when we say heavy payloads, long range, and quick refueling, And when we say there's wider benefits of the hydrogen economy, people are starting to nod instead of just looking skeptical and asking more questions. In the last 12 months, we've seen a real societal shift in the acceptance of hydrogen. And this culminated in our multi-million pound investment we received over the summer from Eurogarage's group, and which will enable us to produce our demonstrator vehicles, and we'll have the van demonstrator, which you can see up here, in 5 months' time, in March next year. That'll be on the roads. One of the most exciting things about working for HVS is the emissions prevention potential. If we reach our production targets by 2030, we'll have prevented the emissions equivalent of Heathrow Airport in 2017. This is a quick look at the two vehicles we're producing. We've got our MCV van on the, I don't know, be right side for you, and our HGV truck on the other side. You can see there's a lot of design overlap. This is deliberate. It's to increase our supply chain efficiency through overlap of components, and also increase our manufacturing efficiency by the same thing, overlap of components, overlap of design. When NMIS approached me to ask me to do this talk, they mentioned that manufacturing is in all the sectors. It's in lots of different businesses, and they're absolutely right. At HVS, we produce zero-emission products, but if our manufacturing was still highly polluting, that would take away a lot of our positive impact. And with manufacturing, it is across all sectors, it is across the whole economy. So we can focus on manufacturing as a sector in itself for decarbonisation. We've got the potential to have an impact across the whole economy. Where we are with HVS right now is we're looking towards manufacturing. There's a lot of planning to do there, there's a lot of challenges and opportunities that come with that. One of the opportunities is we get to choose what our facility looks like. We get to make it work for us. We get to say we want it to be this size because we want to reach this production numbers. We get to say that's where the cranes go, that's where the pits go. We get to make it flexible so we can produce both of our vehicles within the same facility. Another challenge that we're looking into is the balance between robots and humans. In a high-value, high-precision manufacturing environment, there's lots of jobs that robots can do over and over again very precisely that they're very useful for. But there's some jobs that are space-constrained, there's some jobs that are very fiddly, that it would take a lot of effort to program a robot to do. But for human, they can just go in and do it really easily. So there's a lot of work around getting that balance right. Another opportunity is working with government. We're working with NMIS, we put this event on, we're working with SMAS and Scottish Enterprise to try and get as much local supply chain as we can, and also local workforce. On to the challenges. One of the challenges, again, is to do with we're spoilt for choice. We have the proverbial blank slate, and at HVS we're very aware of this choice. Do we want to have a greenfield site? Do we want to go into an existing facility? And the problem with existing facilities is that a lot of them are already taken, are already in operation. We also need to think about transport links. We need to figure out how can our workforce get there. But also, the things that we're producing don't just go on the back of a truck. They're the size of the trucks themselves. So we need to think about how do we move our product on once it comes out of our factory. Another challenge is ramping up the workforce quickly enough. We're currently in pre-production, so the workforce is quite low, but we want to rapidly scale up to manufacture. So that is a big increase in workforce over quite a short time. So again, working with NMIS, working with the government, we want to make sure those skills are in place and the people are in place so we can ramp that up very quickly. The final challenge I want to talk about goes back to a point that I think you made earlier, I might have forgotten it, was that we don't want to over-engineer and overspend, and we don't want to under-engineer and have to play catch-up later. We need to know exactly what we need to get the goals that we're aiming for. And that's about getting the people in place, getting the right people into our team who have been there, done that, and have the t-shirt, who know that's too much to do, that's not enough, and that's just right for what you're trying to achieve. So that's the main consideration that we need to look at in planning for manufacturing in a net zero future. We need to get the right people in place, we need to get the right organizations, and we need to get the right physical place for our manufacturing facility so that we can get a coherent plan in place that we know is going to work. And once that plan's in place, we can walk confidently into that net zero future. Thank you for listening.
Thank you, Daniel. Thank you. Always the tough one being first, isn't it? I now will get your correct title. My apologies for that. I'd like to give a big warm welcome for our next two speakers. Amy Dawn is the Strategy, Communications and Marketing Head at Booth Welsh, and you will be joined by the MD, Martin. So please come and join us. Give them a round of applause.
You're in charge of clicking.
So we're told this is the first time a double act has happened on this stage, so we'll just feel it out and see how it works. Okay, everyone here is okay? Perfect. So, hello everybody, and thank you for welcoming us to the stage today. We've had such a great day so far, I'm sure you all have too. It's a pleasure to be able to talk today about the art of the possible with Environment 4.0. Really interesting that Professor Sir Jim McDonald today was talking about the art of the possible and how we're really starting to move forward with new ideas, new innovations that really are driving us towards net zero. I love what he said about engineering and technology businesses really being at the centre of that, and I think that's something we can all really stand up to, and hopefully we'll give you a very snappy snapshot of that in this short session. So Environment 4.0, what actually is it? So depending on what industry that you're in, depending on what you read, who you listen to, there's various different buzzwords out there, as we all know, and it can get a bit overwhelming. So we've coined another term that we want to throw into the mix with that. So Environment 4.0 is basically what we see as the next evolution of Industry 4.0, and really looking at connecting sustainability-driven technology to be able to help protect the planet. So basically the definition that we see it as really is looking at utilising accessible and cost-effective technology that's available just now to really look at helping businesses achieve both environmental goals, but most importantly actually their bottom line, and making sure there's a really strong return on any investment and really positive impact on profitability. So we'll all be very familiar with the UN Sustainable Goals. There's been an awful lot of chat on that over the past couple of days. There will continue to be over the next week or so as we start to move through COP. But really, these were coined by the UN as really looking at being a blueprint for the next number of years that businesses can work towards to achieve a fairer and more inclusive society. So they're really, really important for us all to take heed of. But interestingly, as we start to think about the benefits of actual digital technology and how we've been supporting our clients, they can actually start to become the drivers to help us move towards businesses achieving these sustainable development goals, which is what we're going to talk about today. And we can see them lit up there. Right first time, remote assistance, waste reduction, energy saving, emission reduction, increased uptimes. These are all things that really help us to be more environmentally responsible in what we're all doing. So the benefits of adopting the global goals are clear. There's a full few slides that we could fill very much on this, but I think most importantly it allows us to actually see as businesses to play our part in the journey towards net zero and what we can do. So we've been working with clients over the last year or so to really look at moving them forward in this journey. So I'll pass you on to my colleague Martin to talk about a couple of case studies that we've got. Do you want the clicker? Do you want me to click?
Thanks. Everybody hear me okay? So, in the last 4 years, Booth Welsh really have been seen as thought leaders, not experts, because there are no experts in digital technology out there, but we've really been pushing the boundaries of digitalisation and what we can do with Industry 4.0. And the presentation title, The Art of the Possible, has actually become the achievable results that we can get now from digitalisation. So this presentation 18 months ago would have featured on what you could do with the technology, but we have 4 case studies here to show you what we have done with the technology now. And I think, as Amy said, there's a symbiotic relationship between delivering digital products and actually achieving the sustainability goals that we all have to achieve now. So I'll take you through 4, very easy, very quick. Any better? So I'll take you through 4 case studies, just demonstrating the abilities and the capability that we have delivered for our clients. The first one, data analysis. So helping the client understand the data that he had himself was actually a challenge, but once we added a few IIoT, low cost, highly effective sensors, and looked at helping him identify a critical problem that he had on the plant, we were able to make significant savings. The cost saving alone was significant, but when you actually look at how we achieved reduced waste, increased uptime, reduced energy saving, actually the benefits were wider than just the project goals we'd set. With a global pharma business, we looked at digital twinning. And interestingly, in this case, we used a mixture of traditional CAD technology and gaming technology to produce a very quick and effective model of the plant, which would live through the through the plant design as we evolve into the operational phase. But we identified some early clashes. Now that's something we've been able to do for quite some time. But using the methods that we had adopted from the gaming industry, we were able to do this much earlier in the process than normal. The significant savings we made there again in the design phase was what we set out to achieve. But on top of that, we identified clashes about operability, maintainability, and driven more benefits from, again, right first time and reducing waste. Remote support has saved the day for the business. We do a lot of control systems and automation projects. These projects rely on the client coming to our premises to accept the system and to do typically 3-4 weeks worth of in-depth testing. Using remote assistance and using remote technology, we were able to do that by using the broadband connection, avoiding a lot of travel, saving significant costs in this instance again, but more importantly for us, assuring our clients that we could still deliver the control systems much needed through the pandemic period. You can imagine the amount of air miles alone that has reduced. And the last one was the Cobalt Technology. So we had a medical devices company based locally who were looking to design a system that would allow them to more effectively create a system to produce a medical device. It was a high cost raw material, it was a very complex project, and they were looking for a more effective way of delivering it than using humans. So again, using 3D technology and using digital modelling, we created it first of all in a digital model. We tested it digitally, and when it came to building, it was the right first time again. So what we did there was we took a lot of the raw material that would normally have been used in testing out, so we reduced waste, and again we delivered the project right first time. So I think as well as delivering project goals, achieving the sustainability targets that we can't avoid, we all must meet. I think there's never been a better time and a more compelling case for using digital technology to produce benefits for our clients.
Definitely, and I think now we're starting to see there doesn't need to be a trade-off anymore. You don't have to choose whether or not you're going to prioritise the planet or profit. You can do both. So that's a wee snapshot of us. Please come and visit us over at the stand. There's still a good wee 15 minutes left for networking or so. Thanks very much.
Thank you. I was going to give you your introduction, your clicker. You are, I said you, last speaker. He is eager, everybody. Ladies and gentlemen, please give it up for Bradley Wynn. Enjoy.
Thank you very much. Hello, my name's Brad Wynn. I'm Research Director at the AFRC, but what I really am is a passionate metallurgist, a passionate metal basher. I'm even passionate about UK manufacturing, even with this accent, which is quite unusual. What I'm really interested though in is actually generating solutions for UK manufacturing today, such that they actually can be in a situation where in the future they can actually have an environmental agenda to exist in. Because if we don't have an environmental agenda right now to deliver a solution, our UK manufacturing sector won't be in existence in 10 years. So we have to actually generate solutions now. And what I'm going to do is give you a little snapshot of some of the technology we've been developing with the Henry Royce Institute down at the University of Sheffield and the University of Manchester to show you how we can utilise waste material that's got an incredibly high value and put it back into a supply chain and make extra value for the UK manufacturing sector. So what I'm really going to say to you this few minutes is making waste titanium a valuable feedstock. Okay, and I really want to show you what waste titanium looks like. That's what it looks like. Okay, so every time the UK aerospace manufacturing sector makes a very structured critical rotating part, for example, it actually machines off normally about 9/10 of the actual component. So we have these things called buy-to-fly ratios. So every 1 kilogram of titanium, aerospace grade titanium that actually flies, 9 kilograms lays as waste. And there you can see that waste. Okay, that waste is there, and that pile is at the Transition International in Sheffield, and that's not a stagnant pile. That comes and goes on a daily basis. So that's moving up and down. So you can see an incredible amount of aerospace grade titanium. Aerospace grade titanium, can you still hear me? Okay, excellent, fantastic, amazing. Aerospace grade titanium coming in and out. But what is actually important is that is the best titanium we have. It just happens to be in really, really small bits. In fact, I could argue actually that's better titanium than actually what goes into an aerospace component, because actually it's been heavily worked by the machining process. So we've got this awesome feedstock that we can make something useful out of. We should be making something useful out of. And the reason is, I'm going to show you why we should, because we're going to have a look at what's happening in the UK titanium sector as a whole. The UK, or actually I should say the world, produces about 120,000 metric tonnes of aerospace grade titanium a year. Of that, UK produces about 5,000 tonnes itself, found mostly in Whitton in Birmingham, and then it imports about 30,000 metric tonnes. So the UK is a big player in titanium, not unsurprisingly. However, we then take that 35,000 tonnes and we forge it and machine it, all exciting stuff. We bash the crap out of it and it's awesome. And we machine it and we make 5,000 tonnes of aerospace grade components. But notice that means we actually have 30,000 tonnes of waste. And that 15,000 of that, 15,000 tonnes is solid waste, and 15,000 tonnes of that is pretty much swarf. And then it goes into those companies like Transition International. It gets converted into two things. It either gets into revert, which is effectively goes for remelting back in the United States, or it gets converted into ferrous titanium, which is effectively the alloying elements for steel making process. And that goes then overseas. So we effectively send away 18,000 tonnes of revert to be remelted back in the United States to re-import again. Okay, and then we export about 12,000 metric tonnes of ferrous titanium to be manufactured overseas to make titanium. Okay, that is an incredible waste. If you want to put that into kind of like energy terms, it's like 1,000,000 and a gigawatt hour at the end that we're wasting. Okay, in terms of energy, incredible levels of wastage of energy, but also waste of resource that we don't really, and we shouldn't be using. So I'm just going to show you now a technology we've developed. In particular, has been developed at the Henry Royce Institute, and we're helping scale that up into full-scale application. And that's called the fast forge process. Fast forge process takes swarf or waste powder. I should point out to you that additive manufacturing also wastes a lot of material. Okay, I'm sorry to tell you all this, but actually additive manufacturing also has a significant wastage, well beyond what the 10% wastage that we say from when you manufacture it. So then we take that waste powder and we consolidate it rapidly using a technology called field assisted sintering technology, FAST. And we can make a block of solid metal in less than 30 minutes from that solid waste. In that case, you can see the scale of that. And that particular solid bit of metal has the same properties as wrought material. Okay, so we've consolidated really great titanium into really great titanium again in about 30 minutes. We can then take that really great titanium and machine it into shape, or we can just do one-stage forging and can generate components, as you see. Generate awesome components, and in fact those components are being engine tested right now by UK automotive companies right now. And then we gain high integrity, low cost components again. And in fact, we believe that we can now manufacture high quality aerospace titanium components than less than 100 pounds a kilogram, significantly changing the landscape for UK manufacturing in terms of the titanium sector, and is significantly, hopefully, generating a new supply chain that maybe even in Scotland you can have a scenario where there's swarf coming in and no more than 100 metres later you can have a fully dense, high quality, high integral aerospace or automotive component that is going to add value and jobs to the UK economy. Thank you very much.
Keep it with you just in case. Thanks, Brad. We had a little bit of a frequency problem there. That's why he had the microphone. I hope everyone heard heard everything. Thank you ever so much. Let's get the conversation going. Thank you to those who've already put a question in the app. If you have a question, you have a few minutes to put it in, because we are going to take a look at the poll. If we can have a look at the poll, please. Gurus in the side, in the back. Okay, what do you think is likely to have the greatest impact on your organisation's use of natural resources? Thank you for voting. I'm going to the first person who sat down, Daniel, having a look at that whilst Brad's taking a break there. What are your thoughts? I think your sound is down, so don't worry about that. Keep me on my toes.
Hello?
Can we hear him?
Now? Yep.
Perfect, lovely.
I think that makes sense. I would say electricity and metal for us would be the two big ones. So that's taking up at least 60% of the circle there. What we're trying to do at HVS is we're a systems integrator. So we don't do a lot of manufacturing of the specific components, but we're trying to work closely with our component suppliers to put, not necessarily pressure, but to work with them to work this into their own supply chain, so they're more likely to deal with raw materials than we would be. And so as the final component assembler, we have a lot of power over the supply chain, and we can work that back through them to use more sustainable forms of energy for electricity, but also to, as we've seen, remanufacture or reuse earlier today for metals. And we're trying to get this kind of almost a polluter pays principle, where it's the people who produce the components kind of own them throughout the lifetime of the vehicles. And then once they're done in the vehicles, or they're not, the battery or the fuel cells being worn out for use in automotive, it could be taken back to the manufacturer, given a bit of maintenance, and then used for another use, such as for street lighting or a stationary application.
Thanks. Amy, any comments on what you're seeing on the screen there? Can she hear you? You can hear me, can't you? You hear me? Probably not, don't you worry. It's last session, they're doing this to get my energy levels going. Thanks, Amy.
We're trying to save energy as well. I think it's an interesting one just to look at there. What do you think is likely to have the greatest impact to your organisation's use of natural resources? I think we'd probably say is also the orange space. I think, what we're starting to see is we can support businesses really to maximise their use of their resources and be more efficient and kind of do more with less. So I'm quite sure Martin's got something to add to that as well.
No. Are you? It's fine. They are doing this on purpose, don't they? There you go, Martin. I'll swap you for that one. I'll get that one fixed whilst you're chatting.
Just think of your steps.
Think of my steps.
No, I would agree, Amy. I think, looking at our business and the use of energy, again, we're a system integrator too, and we're a service provider, so we don't have a lot of raw material issues, but our energy use is predominantly gas and electric, and we've taken great strides towards reducing that. We still have a large boiler I call the Queen Mary we need to get rid of, but the rest of the energy efficiency we've embedded in electric vehicles, for example, and putting in charge points, and we're on that journey.
Last words, Brad, now you've had time to recover.
So I'll speak more on behalf of the now.
You might need to go a bit closer with the mic.
I'll
thank
just
you.
speak a little bit more in terms of our members and our forming and forging companies that we engage with. And as a general rule, the feedback is always reduction in energy and doing more with less. That's basically the theme coming out of all of our companies.
Lovely. Thank you. I've got a couple of questions now for the panel, and please don't make me run round again. I'm out of breath already. So please, everyone, thank you, Chris. I'm going to have to take my glasses off. That's a sign of the times, isn't it? Chris Dungy is asking, are you here, Chris? Oh, well, look, why not? Let's save me the voice and pass that over. Thanks, Chris.
Thank you very much. Really enjoyed all the presentations. Thank you for that. Just a question directed at Daniel, actually, around picking up from the thread earlier today around the design aspects and sustainability. So have you got any insights you could share around how sustainability has been built into your design, particularly focusing on the fact that you've got a new system? So you're in a quite unique position here. And any insights or challenges you could share with us that we should be considering on our own journeys?
Can I take that? It's like table tennis, isn't it? Good job I put flats on today.
It gives me thinking time as well. So the question was about how do we build sustainability into our design. Is that right? Yeah. So, as I said, we are designing our vehicles from the ground up, and it does give us a lot of opportunities. We're looking at as much modularity as we can, so that when we put a component in, you don't have to tear the whole vehicle apart to get it out. We're also looking at, we know that we're in an area where technology is adapting quite fast, and innovation is happening all the time. So we don't want to build a vehicle that's going to last for 10 years, but in 5 years' time, the current technology won't fit into that vehicle, so it'll become obsolete. So we're trying to create flexibility within the vehicle platform to be able to upgrade components to the more efficient components we expect to come in the next couple of years. Also looking at our digital systems, we've heard earlier today that in the digital realm it's moving, as we know, far faster than the physical realm does. So instead of building our dashboards with limited capacity and kind of just creating it to the spec that we need for today's digital components, we're looking at making our dashboards with kind of over-engineering them so that there's plenty of computing power, there's plenty of inputs available for future technologies that will come along, future smartphone technologies, future connected technologies that don't exist yet, but we know that they're going to be used in vehicles soon. So there's a lot of design work around that, and it's just about being aware of what's happening in lots of different sectors. It's just about taking that knowledge in, designing flexibility into our vehicles to make sure that when this technology comes, and we know it will, we can adapt to that when it's there.
Thank you, Daniel. Thumbs up on the answer of the question. Fantastic. Kim McCann, where are you? Oh, lovely. Let's get the microphone over to you. Brad, that's hilarious because it's a question for Brad. I didn't win then, did I?
I can walk over and hand the microphone back if you want.
Kim, go ahead.
So, can you hear me? Is this one working?
Yes, it's perfect.
So, Brad, my question was around, can this sort of circularity of materials and supply chain in a material like titanium that is high value, do you think that we can do enough with that to create a kind of global competitive advantage in having that self-supply, if you like, onshore, that means that we could actually use that to grow and develop the automotive and aerospace sectors in the UK even more?
Absolutely. So we have a large number of consortium involved in the development of this work, both aerospace, but very luckily for us, a number of automotive companies are very interested in this technology, with some of them expecting to have components in service by 2025 in using this technology. So the answer is yes.
Nice, snappy answer there. Jack. Lovely. We've got Jack over here. Jack, put your hand up again so that we can get the microphone over to you. Thank you for your question. And you can let us know who it's for, if it's for all the panel or for one panellist in particular. Jack, over to you.
Lucky for you, it's for Brad again, so you don't actually need to run anywhere with the mic.
Thanks, Jack.
No bother at all. Planned that. Again, so to Brad, kind of following on from the last question, actually getting value from this process. You also teach me materials as well, so this is really interesting for me. How close or homogeneous is the microstructure produced from the fast forged titanium compared to the raw material?
I'd like to congratulate you on your materials knowledge. That's an excellent question.
Bonus marks in the exam.
Okay, so one of the really important issues about traditionally manufactured titanium is that the microstructure is quite varied in a forged component or a forged billet. One of the really additive advantages of fast is actually the microstructure and the material properties are isotropic, very, very isotropic. As a consequence, actually, we believe that in fact actually we'll be able to use more potential of titanium using the fast process because we don't have to put in as large a safety factor because of the unknown variation in the microstructure. So therefore we'll actually be able to have more confidence in the design, so we should be able to use less titanium for the same equivalent product and have the same level of confidence of performance in service.
Answered the question. Lovely. Thank you. I'm just conscious of time. We have a question from Rosa. Rosa, where are you? Oh, sorry, I can see you there. You're now making Dan run over. I'll take that seat back. Thank you, Rosa.
Thanks, Dan, and thanks, Sammy. My question was about alternative resources. We know that in certain areas there are severe resource constraints. We've seen some of the challenges acquiring lithium for lithium batteries. Should our governments be investing more in investigating alternative resources where there are those constraints? And if so, what should they be doing?
Answer that question, Mark.
I think we'll probably start
with
sorry, Brad. Over
Hot
to you.
spot, Brad.
It's a really interesting question. The reason why we use certain materials for certain application is we're confident in their quality. So it's a long process to get a new material into particularly a structure critical process. So if we're going to do that, and we should, particularly in the case of lithium is a good example, particularly in fusion reactors is a good example where lithium is going to be an issue. We have to start the process early. We have to have a chain of technology development from low TRLs all the way through to pushing the boat out. But we don't have that. I always go back to something I heard from Airbus a long time ago. Titanium 6.4 is and always will be the alloy of choice in the aerospace industry because they have absolute confidence in its performance in service. And until we can get to a scenario where we can use digital technologies to rapidly translate that confidence, we'll never go into other materials because we always have this safety critical element in our scenario if it's a safety critical problem. That's my opinion.
Thanks, Brad. Does anybody want... They're all looking. Yes, Daniel's looking. Oh, and Dan's running over in those closing words there. Thank you, Dan. Over to you, Daniel.
Yeah, lithium ion is obviously a very interesting point because there's a lot of it in South America, and a lot of the high altitude lakes are being destroyed by the water resource required for lithium ion mining. And in cobalt, there's a lot of unknowledge, I'm not sure what the right word would be, around where that comes from. It all kind of goes into one stream, and we're not sure where all of our cobalt comes from. There's a potential it might come from artisanal child slave labour. So there is a lot of work needed to be done around where we get our precious metals from and our alternative resources. I think from a HV Systems point of view, as I said, we're the systems integrators, we're not the component suppliers. So our main goal is to get our vehicles on the road as quick as we can to start reducing transport emissions. But your point's very valid, and we do want to put, as I said, pressure onto our supply chains to make sure that they are not overusing these rare earth materials. But also into R&D. I think that's a big part the government can do is invest in R&D so that we can use lithium-ion batteries at the moment, we can use platinum-based fuel cells at the moment, but the R&D is in place to get other alternatives coming through the TRL timeline so that in 3-4 years' time when the lithium problem could be much worse, we do have these alternative technologies in place. They have been tested up to a marketing level, and we're able to use those in the real world and actually start making emissions differences and efficiency differences.
Thank you, Daniel. I think you must have seen that clock dropping down as you ended that sentence. Ladies and gentlemen, can you give a big round of applause for all our 4 speakers, Amy, Daniel, Martin and Brad. I don't know where the time is going. I'm happily sitting enjoying the conversation, then realise that we are at our closing keynote sessions now. It's 4:10 on what has been a great day of conversation. First up, I was panicking because I didn't see him, but now I can see him. I can breathe again. Our first closing keynote is the inventor of a number of innovations that make up the hybrid water heating system. I hope I pronounced this right, Nick. Hiru. Yes, you'll tell me if I'm wrong. Nick is going to tell us more about this during his session, but it will be installed in homes and businesses to significantly reduce waste. It's going to affect us all positively. Here to talk about the story of true innovation and invention, solely with sustainability at the very heart of it. Please welcome, I think he's got the microphone due to high frequency, the CEO of Manic Venture Limited. It's Nick. We'll bring Nick on, but we're just going to check his sound before you give him a round of applause. It's a bit like the Crystal Maze, isn't it? Where's the gin and tonic van? Ladies and gentlemen, please give it up for Mr. Nick Spencer. Got it next there.
Thank you very much, and I feel honoured to be here in such incredible presence and at such an incredible week as well, to be honest with you. It looks as though our global leaders are hopefully making some progress, and it's really, really good to see that they're actually not just looking at the CO2 emissions, but they're also considering the other pollutions. And methane yesterday came up, and they're actually talking about a significant reduction in methane, which is obviously far more harmful to our environment than CO2 emissions. But I think also, I'll talk a little bit in a minute about the background, but we see all these striking images on the news and in our press, and with Sir David Attenborough and his programmes and Greta. And I think that the images of the actual waste that we see floating around as a form of pollution, unfortunately that doesn't seem to be being discussed too much at COP26, because it seems to be more about the air rather than our drinking water. But also just a little thought, and I know I'm in a room of engineers here, and I'm not an engineer. I got chucked out of school when I wasn't.
Sorry, Nick.
Is that okay?
Is that better?
Is that better? So I'm not an engineer. I went to agricultural college and came out and went into the waste industry. But tyres was something that's really interests me, because you buy a new tyre, and there's 30 million cars in this country, and they've all got a tyre on each corner, so potentially 120 million tyres wearing out every year. And where does that rubber go? We know we've seen plenty of evidence of where the tyres go after they're being disposed of, but where's that rubber going that's actually coming off the tyres? And if we're making our cars out of electric and they're going to be heavier than a combustion engine, are we going to create more tyre wear? And I'm assuming that tyre wear, that 4 or 5 millimetres that we lose off the tyre, is washed down the water stream, and then we end up drinking it. So my background is the waste industry. I came out of school and went to agricultural college, studied animal husbandry, started making animal bedding for racehorses when I came out, put it into the racehorse trainers because it could control the diet much more closely if they were on paper. And I couldn't get enough newspaper, so I started going around people's houses collecting it, and by complete accident set up the first commercial curbside recycling company in the UK, which grew very, very quickly. We ended up then with more paper than we could process ourselves. So I actually built up a business where we were exporting at the peak about 250 shipping containers a week of material. I sold the business to Biffa in the middle 90s, and that became Biffa's sort of first recycling business in the UK. And then I went on in 1999, the landfill directive came on, and so I invested in 180 recycling vehicles through WCR and sold that in 2000. Then I built Pure Recycling. I found some technology in the USA that could tell the difference between a perfectly roasted peanut and an over-roasted peanut using neo-infrared beams of light. I brought the technology back to the UK and remapped it to tell the difference between PET plastics and HDPE plastics and the polypropylene. We built a 150,000 tonne plant called Pure Recycling, and I sold that to Kia, another PLC, in 2010. So the 1999 landfill directive came out, and we saw some really, really very bizarre behaviour. The first was really that it was all driven by weight. So the local authorities were targeted by weight. So they gave everybody a wheelie bin made out of plastic to put their garden trimmings in, which before they were composting at home, because the garden trimmings are the heaviest fraction in terms of quick recovery. They'd put on another refuse vehicle doing about 4 miles to the gallon to go around collecting this garden waste, and then they'd make it into compost, and then it wouldn't meet the PAS 100 grade, so you couldn't actually sell it, so they ended up putting it on the landfill sites as landfill cover. That goes on today still. Plastics became even more bizarre. When I built that new big facility, we were asked by local authorities, we need to take the pots, tubs and trays. And we say, well, we can't take the pots, tubs and trays. There's no market for pots, tubs and trays. We can sell the PET and the HDPE. And Coca-Cola, in the Panorama program that we probably saw last week, demonstrated just how difficult it is, even to recycle PET, which is the most recyclable along with HDPE. So the pots, tubs and trays, as an industry, the public have been told we can recycle it just because it's got a label on the bottom of it to say it can be recycled. And the waste industry is faced with this situation where it's going to have to take it if it's going to win a local authority contract. So we put the material in with the HDPE and the PET and mix it up, and we'll bale it up as a mixed grade plastic, and then we'll ship it to Indonesia, Vietnam, Malaysia, China up until 2 or 3 years ago. And then they take out the PET and the HDPE. And so whenever you watch those panorama programs, you'll always see lovely piles of PET and HDPE, and the stuff floating around in the rivers and the sea is pots, tubs and trays. So we converted the rivers into very, very cheap conveyor belts, which are unbelievably reliable. They never break down, and we just ship the pots, tubs and trays to the ocean. And that's the unintended consequence of a piece of legislation that was linked to our industry and is what's really causing the sort of main driver of plastic pollution. So I wondered whether we could look at it from another direction. Having spent all 30 years in the waste industry, I wondered whether we could create a device that could go in the home and the business, and you would pyrolysize the material, so you heat it in the absence of oxygen. So pyrolysis, if you take a tree and a dinosaur and you buried it for 5 to 9 million years, it'll eventually turn into oil, gas and coal. So this piece of technology does the same, but in 5 hours instead of 5 to 9 million years, using the heat pipe, which was developed by NASA originally for taking the heat off the front face of the space shuttle. And I'd been reading about it, and I thought, I wonder if I could amalgamate that with the Stephenson steam engine principle, where he ran the pipes through the chamber, and create a chamber that I could pyrolysize material in. So shortest route to failure in terms of engineering. We'd try nappies, and we'd see whether it worked down at Brunel University. And it did work very, very efficiently. So that was basically the start of the journey. We've now got the technology. It's run for 10,000 hours in the field with Wychavon District Council, Rugby Borough Council, Social Housing Department. So we're looking at tackling fuel poverty as well as taking the waste away from the waste stream. It's important to say that the HERU isn't a waste unit. The definition of waste, legal definition of waste, is if the holder of the material discards it with no further purpose. So we took a legal opinion as to whether if you eat, or you've got a sandwich, you eat half of the sandwich to energize yourself, and then you put the other half of the sandwich into a HERU to energize your home, has the half that you haven't eaten become waste or not? And the legal opinion was that it wasn't, because otherwise you'd have to class every human being as a waste incinerator as well, or a waste disposal unit, because we produce gas too. So that was really important in terms of the project and making it very, very important. So we keep the cartilage. We created these units in trailers so we could move them around. So it's a house on wheels, basically. So this is what it's all about. CO2 reduction. Also massively important is the methane reduction, because we're not putting the waste into the waste stream. So in that top right hand corner, you've got a gas boiler in your home, in the average home size of about 68 metres square, producing about 1.6 tonnes of CO2 per year with a curbside collection and a gas boiler. So move down into the bottom left hand corner. The government is saying they want to put air source heat pumps into properties. Most properties won't be able to take air source heat pumps because the insulation won't hold it. And so then you move along to the HERU, which is a CH4 HERU solution, minus 80 kilograms of CO2 compared to the 1.6 tonnes positive. And as we move forward, we're going to put hydrogen onto the grid, 20% initially, and then we'll put electrolysis on the HERU so we can end up with an off-grid HERU, but that will come a bit further down the line, and that will make the swing from a positive 1.6 tonnes to a minus 475 kilos. This was all done by Ricardo, the life cycle assessment company. So in terms of manufacturing, which is the expertise in the room here, and I'm not a manufacturing expert, but my goodness me, it's challenging bringing new technology to market. I had no idea when I set off on this journey just how difficult it would be. I've had massive support from Siemens, and that's really, really helped us so much. but you don't know what you don't know, which was really interesting because the speaker earlier on was saying exactly that. And so it would be fantastic if you could have a forum of perhaps people like Dyson and obviously Sir William Seaman and people like that, that when they were going through this journey from startup to scaling up, and Bosch have done the same and so many other companies, but that never gets shared really. And I was talking to someone earlier, and apparently Dyson has released a book just a few months ago, so I'm going to be buying that this evening. But yeah, that's the challenge, is scaling up into volume production. We've got our first 11 machines being produced, the 125 litre machines. So we're going into the commercial sector first. So we've got very high profile customers, including the NHS and Facebook taking our first machines, and Siemens, of course. So that's where we are. And I think that's it. Thank you.
Thank you, Nick. Super. Thank you. Time went. Do apologise about the sound there. We lost the frequency a little bit, but now we're back. Everybody can hear me on this microphone, which is not as important as you hearing our next speaker. It is definitely working, Catherine, and I will be your clicker if you need me. Catherine Bennett joined the HVM. Has it gone, or you can hear? You can hear, great. Catherine joined, as I said, the HVM Catapult as CEO in June this year. So fairly new. Following a 16-year career at Airbus, most recently as Senior Vice President. HVMC has 7 centres across the UK, from Bristol to Glasgow, and Miss is one of those. Here to close out today with reflections of the event and to look forward to the future, please give a very, very big round of applause to Catherine Bennett.
Well, good afternoon, good evening, and thank you for staying to hear the keynote. And Nick, it was fantastic to hear your story, and good luck with your project. Thank you, Sam, for the introduction. As Sam said, I'm the CEO of the High Value Manufacturing Catapult, and joined this august organisation back in June this year, having been at Airbus, and before that I worked for General Motors. And it's wonderful to be here in Renfrewshire to meet all of you today. I do have one thing as a former employee of Airbus. I'm not sure what Bradley was talking about when he said an electric car has more items in the supply chain than an A380. I think I may have to challenge him on that, but I'll go and check into the detail. But hey, listening to these sessions today, hasn't it been incredible? And I feel amazingly motivated by hearing the stories of some of the people that you've collected together. At the opening speech of COP26 on Monday talked about the fact that we've got 1 minute to midnight to make a difference on climate change. And boy, have we got some stories here that we can really contribute to the net zero challenges we all have. To host this event. This very building where I'm talking to you from has been opened recently as one of the newest centres of Boeing, working with the National Manufacturing Institute for Scotland. So a great place to start this conversation. I came to visit this site as one of the first centres within the High Value Manufacturing Catapult back in July. I was delighted. It was the first centre I visited. I had a super visit, and I don't know if any of you have seen it, but the amazing new building that's been built near the airport with a purple roof. As some of you may notice, I like purple. So have a look at that building, and I know there's more news to come. And of course, the National Manufacturing Institute of Scotland isn't the only part of the catapult that's here. We also have the Medicines Manufacturing Innovation Centre right next door, which is part of the CPI Centre, which is also part of the catapult. Obviously specialists in medicines manufacturing, and more news on that to come. So we in manufacturing must take the steps to drive down greenhouse gas emissions and protect our planet that we've been hearing about over the last few days. And of course, the vital role that manufacturers can play mustn't be underplayed. we've got to meet the challenge. As Will Mitchell from 4C Design said earlier in one of the other panels, there are difficult decisions. There are difficult decisions we've all got to make. But actually the most important thing is to just get on and make those decisions. Every business and every person in this room has a role to play. And I'm sure you all recognise the importance of working together, learning from each other. Go and have a look at the stands if you haven't yet, and hear some of the stories. And we should celebrate the wider role that we can play in helping drive back climate change. You are the people. You are the people. I've met some of you today. It's been wonderful to meet colleagues from the National Manufacturing Institute just along the row there and hearing some of the work they're doing. Whether it's low carbon heating with better insulated homes, low carbon energy suppliers, looking at the renewable and the nuclear sector, low carbon transport, we heard from Daniel talking about the work his company are doing. Whether it's in the air, such as my former industry, working on lighter weight electric vehicles, alternative fuels, the low carbon approaches to production. And it's really important that we have consumer confidence that these products are being made in a sustainable way. But we cannot reach these climate change objectives without us all working together. And today, I hope you've been inspired by some of the things you've seen and heard. And there are maybe some ideas you can take back to your business. And I hope some of the ideas are developing about capturing new market opportunities. I mean, that's important, of course, for any business to develop its market potential. And the help is there for you to make this change. So the whole of my organisation that I'm honoured to be leading now, the High Value Manufacturing Catapult, has made a new commitment. We've just done our new strategy to help you to drive down carbon emissions from the operations or the things you produce. Every one of our 7 centres at 18 sites across the UK, with the support of Innovate UK, has made this commitment to help your business harness the latest technology and thrive. We are working hard to help businesses such as yours evolve the products, processes and technologies that will make the difference. Let me just give you some examples. Think about the projects to develop new lighter composite turbine blades that cost less and generate more. I was invited earlier to have a chat to the offshore renewable energy catapult over there and hear the work they're doing on wind turbines. Think about the projects to help the UK harness the potential of hydrogen, one of those new industry sectors that we're all interested in. And I was delighted to hear more about the work being done on that from a colleague from Scottish Enterprise last night. Tomorrow at COP, they're talking about energy. So we should ensure that manufacturing is part of that discussions. And Monday's COP discussion was all about fossil fuels and reducing the use of coal. And this is where, again, the work that we do in the nuclear sector can really make a difference. There's a myriad of projects to drive the electric revolution and accelerate the shift to zero-emission vehicles. We can work on action to make our buildings more energy efficient and support the move away from fossil fuels while keeping bills down. Now, yesterday at COP, they were talking about trees and deforestation. CPI, one of our centres based in the northeast, have been involved in formulating biodegradable plastic for the tree planting industry. So I've been amazed ever since I joined back in June to hear about all the work that's been done across these amazing sectors we have in the UK. Now, I know that innovation can feel risky. We can help at the Catapult and all our centres and our 3,500 employees across those centres. We can help de-risk the innovation. We can connect you to the right kit, the right expertise. And let me say this to you, innovating should not be the risk you worry about. With your ideas, we can help turn them into successful realities that not only save the planet, but improve your bottom line. So if yesterday at COP was all about trees, Today, and I was delighted to see this on the news this morning, was all about finance. But of course, money does not grow on trees. We know that failure to act on climate change will have consequences. There will be higher costs if you don't act. We'll have trouble recruiting people. We'll find it harder to find that finance, to find the investment. Ladies and gentlemen, the future is in our hands. As we leave today, let's all think about how we can protect that future and make it a bright one. At the beginning of COP on Monday, I listened to the words of the poet Ursa Daly Ward. This is what she had to say. Anything less than your best is too much to pay. Anything later than now, too little, too late. Nothing will change without you. So those of us in manufacturing should continue our work to answer this call. Finally, in closing, and I've been honoured to speak to you now, and well done, Sam, for emceeing this with all the technology, and I've been honoured to stand here on the stage. As I said to Sam earlier, I felt a bit like I was going to be Madonna, but luckily I had no headset in the end. But a huge thanks to all of you who've exhibited here. It's really been a privilege and a pleasure to see you all, and I know that putting an exhibition stand together takes a lot of effort and investment and time. Thank you to my colleagues from NMIS for being here today and talking to the people visiting. But I want to pay a special tribute to Debs Finlay and Stuart Laidlaw, who put this event together with a matter of few weeks. And I know they also were challenged by falling ill with COVID. So isn't it incredible what we can do? So I just want to say thank you, and let's get on and ensure that manufacturers can be part of the solutions for the future. Thank you, everybody.
Thank you, Catherine. Well, that is it. Yes, thanks. Great thanks to Debs and to Stuart. Debs and I became twins because we got tested positive of COVID on the same day. Yes, it's been a journey. Can I also say thank you to all our speakers who've contributed today. It's been great. The goal this morning, my first words were, the goal was to inform and to inspire, and I hope that you are all leaving now informed and inspired. I'm seeing people nodding. That is great. We have achieved the goal. Please keep that conversation going. Another final thanks is to all the men and the ladies in black over here who've kept the sound going, kept us moving, kept us building. So a great big round of applause to all of you in team production. Thank you very much. It's been an honour and a privilege. Please get home safely. Before we close out, say your final goodbyes to the exhibitors. And speaking to one of the MMIS colleagues, we may see you again this time next year. Safe home, everybody.